Hey everyone. So if you're just starting your pharmacy journey, get ready to meet one of the oldest, most fundamental tools in the entire field, powders. Now, I know, they might seem super simple, right? But trust me, mastering this dosage form is like learning the alphabet of pharmacology. It is literally the original medicine, and you're about to see why it's still so incredibly important today.
Okay, so here's what we're going to cover. We'll kick things off with the basics, what a powder actually is. Then we'll get into the pros and cons. After that, we'll check out all the different types before tackling some really fascinating real-world challenges in a section I like to call the Pharmacist Puzzle Box. And finally, we'll wrap up with the techniques you absolutely need to know to get the perfect mix. Sound good? Let's jump right in.
So first things first, what are we even talking about when we say powder? Before we get into the nitty-gritty science, just think about this for a second. For literally centuries, the main way to create a medicine was to just grind up herbs, minerals, and other ingredients into a fine powder. This is where it all started. But let's get the official definition.
Now that definition might sound a little dry, but it gives us two huge clues about a powder's power. First, it has to be homogeneous. That just means it's perfectly mixed, so every single dose has the exact same amount of the active drug. And second, it's finely divided. All those tiny little particles create a massive surface area, which is a big reason why powders can get to work so quickly inside the body. It's this simple form that makes them so unbelievably versatile.
Okay, so if powders are so great and versatile, why isn't every single medication a powder? Well, like any tool in our pharmacy toolkit, it's got a very specific set of strengths and weaknesses, and we have to know both to use it the right way.
And this slide really lays out the trade-offs, doesn't it? On the one hand, powders are super stable chemically because there's no water around to break down the drug. And like we said, because of all those tiny particles, they act fast. But the downsides are pretty major. You can't hide a nasty, bitter taste. And that huge surface area we talked about, it also means they can act like a sponge for moisture in the air. This is a huge problem for certain drugs we call hygroscopic. They literally suck moisture right out of the atmosphere.
All this versatility has led to a whole family of different powder types. And as a pharmacist, knowing these classifications is absolutely key because each one is engineered for a very specific purpose.
So we can pretty much break them down into two main groups. First, you've got divided powders. You can think of these as little pre-measured single-dose packets. They're essential when you're dealing with really potent drugs where every single milligram matters. Then on the other side, you have bulk powders. This is where you get a whole container of it with multiple doses inside. These are perfect for things like antacids or laxatives, where being off by a tiny bit isn't going to cause a problem.
And if we dive a little deeper into those external bulk powders, you'll start to see stuff you probably recognize. You've got dusting powders for the skin, insufflations, which are, well, they're basically powders that are sprayed into places like the nose or throat. Then there are snuffs, which are inhaled, and even dentifrices, which are just the old school name for tooth powders.
So back to that bitter taste problem we mentioned. How did pharmacists deal with that back in the day? Well, one really ingenious solution was the cachet. It's basically a little edible pouch made of rice paper. You'd seal the nasty-tasting powder inside, dip it in water to make the pouch soft and slippery, and then swallow it. Pretty clever, right? A simple but really effective way to get the medicine down.
All right, this is where it gets really interesting. This is where theory crashes right into practice. Powders can throw some really unique curveballs at you, and solving them requires a pharmacist's scientific brain to make sure the medicine is both safe and effective. So, welcome to the Pharmacist's Puzzle Box. Okay, puzzle number 1. Imagine you've got a powder with a really strong-smelling ingredient, something like menthol. Well, over time, that smell, and more importantly, the active ingredient itself, can just poof, evaporate into the air. So how do you keep the medicine in the medicine?
The solution here is actually pretty low-tech, but it's super effective. You just create a better seal. By using an inner layer of wax paper and then a thick outer paper, you're creating a physical barrier that literally traps those volatile bits and stops them from escaping. Simple as that.
All right, next puzzle, the clumping conundrum. You know how we said some powders act like little sponges? Well, when they pull all that moisture from the air, they get sticky and clumpy. And that's a huge problem for a patient who needs to measure out an accurate dose.
So to solve this one, we can actually attack the problem from two different angles. First, we can turn the powder into granules. This actually reduces the total surface area that's exposed to the air. And second, we protect it with better packaging, like using that double wrapping technique, but maybe with an extra layer of moisture-proof foil.
Now here's a really weird one. You have a crystal powder that is perfectly dry when you make it, but over time, it just gets damp all by itself.
It's not pulling water from the air, it's actually sweating out its own internal water. We call this the water of crystallization.
The best way to fix this is to just use a version of the ingredient that doesn't have that water in it to begin with. We call this the anhydrous or water-free form. Another trick is to mix in an inert powder like lactose, which can act like a buffer and soak up any water that does get released, keeping the whole mixture nice and dry.
And now for our last and probably most famous puzzle. It's the mystery of what happens when you take two perfectly solid dry powders, you mix them together, and they spontaneously turn into a puddle of liquid. What in the world is going on there?
This totally wild phenomenon is called a eutectic mixture. Basically, the two substances react in a way that creates a new mixture with a melting point that's way lower than either one on its own. The key to stopping this is to keep the particles of those two powders from touching each other. You can either dispense them in separate packages, or you can mix each one with an inert absorbent powder first. That basically coats the particles and keeps them from reacting.
Okay, so solving all those chemical puzzles is one thing, but making sure your powder is perfectly uniform and safe is a whole other critical skill. And this becomes absolutely non-negotiable when you're working with super potent drugs where even the tiniest mixing error could have serious consequences.
When it comes to potent drugs, there is one technique that every single pharmacy student has to master. It's called geometric dilution. It works like this. You start with your smallest ingredient. That's the potent drug. Then you add an equal amount of your filler powder, or diluent, and you mix it really well. Then you add an amount of diluent that's equal to the total amount of stuff you have in the mortar now, and you mix again. You keep repeating this doubling process until all your diluent is gone. It's the only way to guarantee that the active ingredient is perfectly and evenly spread throughout the entire batch.
Now, of course, there are other ways to mix. Spatulation on a tile is great for small amounts, and it's also good for those eutectic mixtures because you're not applying a lot of pressure. Trituration is just the fancy word for mixing in a mortar and pestle, which also grinds the particles down. Sifting gives you a really light, fluffy powder. And then tumbling, in a giant rotating blender, is how they do it for huge batches in the pharmaceutical industry.
Phew, okay. We have gone all the way from the basic definition of a powder to solving some pretty complex chemical puzzles. So, what are the absolute must-know key takeaways that you should carry with you as you continue your studies?
You know, if there's one single thing to remember from all this, it's that powders are deceptive. They look simple, but handling them correctly is a masterclass in pharmaceutical science. As a pharmacist, you have to be a chemist to predict problems like eutectic mixtures, and you have to be a technician to perfectly execute techniques like geometric dilution. It all comes back to making sure that something that looks so simple is also perfectly safe and effective for the patient.
And that leaves us with one last big question. We live in an age of advanced biologics, targeted injections, and complex tablets. So why does this ancient dosage form, the simple powder, remain so essential? I think the answer is in its incredible flexibility and adaptability. It's a great reminder that sometimes the most foundational tools are also the most powerful. Something to think about as you continue on your journey. Thanks for joining me.